Hello everyone. So let's start the fifth program. The title of the fifth program is Implement ESS with a transmission node in wireless LAN and obtain the performance parameter with respect to the transmission of the packets. Okay, obtaining this performance parameter with the transmission packets is the work of my AWK script. But one important thing in this is how to implement ESS. What is ESS? ESS is nothing but Extended Service Set Module of my wireless transmission. Extended Service Set Module of wireless transmission. So this is a special program for wireless local area network, wireless LAN. Till now the previous programs what we have discussed, everything is wire network. But only one program in the syllabus he has added for wireless LAN. So now we will see how to design the TCL script or how to design a wireless LAN with respect to ESS transmission node, and what are the parameters I need to consider in order to calculate the amount of packet transmission with respect to AWK script. Okay. So here you have to represent the wireless LAN. So generally I have to represent a grid structure of some X and Y axis, because I cannot say if it is a wireless means a complete universe can also be taken for transmission. But the efficiency or the evaluating some of the parameters may be very difficult, and it is a complex task. If I represent the wireless transmissions within some particular X and Y axis, like if I say a grid of some X into Y, then within that all the nodes should be transmitting their packet or they are communicating each other. Okay, so we will start with respect to a code. So as you know, initially I should create an instances with some particular name my_ns, then I have to open some trace file and then num animator file. Then a procedure is used to finish the execution. Once the execution is finished, I have to flush through everything whatever the data is stored. So here for wireless transmission, I have to create a topology, a graphical structure in order to store or in order to have a transmission within that particular area. So for that, the flat grid of size 2000 into 2000 has been selected. Okay, so this is a grid structure. Then it is also access for non-trace file for wireless media. The same value can be given. Okay, 2000 cross 2000, that is X and Y axis grid value. So if I go with the wireless transmission, then some of the parameters I need to remember where I have to initialize the thing for better transmission. Okay, so here generally ad hoc routing algorithm is used where a particular protocol AODV is considered. AODV is nothing but ad hoc on demand distance vector routing protocol. Ad hoc on demand distance vector routing protocol. So which is mainly used in order to have a proper transmission of packet with the shortest distance from source to the sender. So what are the parameters I need to consider for this transmission? So first I need to say what type of logical type you are using. Okay, the logical type is logical link, and which is the MAC type protocol according to the IEEE standard. The MAC type is IEEE 802.11. As you know, dot is represented by underscore. And what type of queue is allowed? The queue type is drop tail. And what is the queue length? The queue length is equal to 50. And which type of physical media you are accessing? The physical media is wireless. And the transmission channel media is also wireless channel. Okay. Then what type of propagation you can access for your transmission? So we have n number of different types of propagation when you study the wireless communication concept. So here we have taken two-ray ground a structure. Two-way ground propagation media is accessed. Then I should have some antenna in order to send and receive the data across sender and the receiver side in the form of wireless physical channel. So type of the antenna is omnidirectional. That means in only one direction I am sending the information or receiving at the receiver side. Then the topology instances is represented by a name $topo. It's an inbuilt function. Then what type of agent trace and the routing trace should be on? The trace file for the router or the agent, everything should be on for this configuration. Okay. For wireless transmission, all these parameters compulsorily I have to define. Okay. After defining that, I will be creating a structure, or I will be telling it's just like a object descriptor. It is nothing but an object descriptor, that is create hyphen God4. That means a number of nodes in the system, that represents number of nodes in the system. So number of nodes in the wireless channel within this 2000 cross 2000 I will be selecting as 4. So here the 4 nodes I have declared: N0, N1, N2 and N3. Okay. So one more thing what you have to remember here is, in wireless interface, the lower 2 layer of TCP/IP stacks are modified. Okay. The lower only 2 layers are going to modify and all the other layers are remain same. Okay. So now I will give you the label for the nodes. N0 is my TCP1, N1 is a Sync1, N2 is another TCP and N3 is Sync2. Okay. So as the grid structure is 2000 cross 2000, I have to tell how the nodes N0, N1, N2 and N3 are placed within that grid structure. I have 2 different types of representation. You can go accordingly this set does, or you can give individual for all the 4 nodes N0, N1, N2, N3. So N0 with respect to XYZ plane, N1 is in terms of XYZ plane, similarly N2 and N3. Just I have given where actual position of N0. From X-axis at 70 distance, 70 meter or kilometer, that is just a weight. According to Y-axis 70 and Z is 0. So as you see in all the 4 node declaration, Z is 0 because I have selected only 2 dimensional. Okay, so 3rd dimension is represented with respect to 0. Okay, and whatever these values are there, that should come within the grid area. Okay, so this is a representation of each node where it has to present in the network. So then I have to say, I have to declare all the higher layers. Higher layer, transport and the application layer protocol should be initialized with respect to the source and the receiver node. Like I have, as I said, 2 set of source node are there and 2 set of receiver, TCP2, TCP1 and also Sync1 and Sync2. So accordingly I have to declare the respective agents. So I hope you can easily do this particular operations as you have gone through the previous few experiment. Okay. So then I have to give some events for start and stop operation, when my FTP1 should start and FTP2 should stop, and stop duration and what is the final finish time. Okay. So here then finally the run execution. So the main important idea here it is how to set or how to configure my particular wireless protocol. Here I have taken AODB. We have a number of different set of wireless protocols. Any protocols you can take, accordingly you can assign their configuration. Okay. And one more second case changes is how to access 2-dimensional nodes N0, N1, N2, N3 within that particular plane. Okay. So if you incorporate these few changes in the program, then you can able to implement a wireless network. Okay, so for this, if you want to calculate what is the amount of number of packets sent or the received, so that will be accessed by means of a particular statement. Okay, here I have taken in terms of CPI. Okay, let me change this with respect to TCP. Okay, let's assume TCP packet only. Okay, I will access the TCP packet transmission. So now we'll see how the program is executed. So I have given the path, a particular path has been selected. So let me open the program. So NS, okay, first I will open it, gedit, lab5.tcl. Okay, program is opened. So let me execute the function program. So ns space lab5.tcl ampersand. Okay, so when you execute this program, you will get a relevant statistical result also, as well as the NAM file is generated. So when you see this, so when you see this, the total amount of packets sent is 32,144, and similarly the total packet received is 32,066. So sent and received. So the received is little bit less than this sent because of wireless channel. So in between the wireless transmissions, there is chances of adding message should be corrupted. Hence the amount of packet is dropped. Okay. So now we will see how the wireless transmissions can taken place, how from source to sender, how it executes. Initially nothing. Okay. So I have given some particular time when it has to locate along x and y axis a particular node in this NAP animator. So after that particular instant of time only the nodes will be located. So let's start the execution. See, after some points, few seconds, the TCP Z1, sync 1, sync 2 and TCP1. So from here TCP1 will send here to here, one set of communication will take place, and from here to here another set of communication takes place. So if I increase this transmission speed, just I am changing the step size so that you can view the transmission. So at 35, I think 35 millisecond, let me change. Yeah, after some 100 millisecond, the sync 1 it started sending the information to, TCP1 is started sending the information to, from 100 millisecond, this TCP1 is sending information to sync 2. Okay, this is about a wireless transmission case. Okay, now in the program, if you do the changes with respect to a grid structure, with respect to its XY axis direction, or the place movement of this node, where it has placed, whether it is near or the far away, so all those things matters for number of packet transmitted. Okay, if you say all the nodes are very nearer to each other, then the packet transmission will be less. If the simulation time is less, then packet transmission number is also less. So you can vary those parameters and you can get the inference and you can tabulate all the results. Okay, this is about the wireless transmissions for ESS, that is Extended Service Set Ethernet LAN. So wireless LAN 802.11. Okay, thank you.